Here we're going to discuss working with null values. SQL Server data types allow for null values. Many languages, such as those with Visual Studio.NET, do not, and this presents challenges for the developer. Native CLR data types found in the .NET framework do not allow for null values. So developers wishing to integrate T-SQL with a CLR language such as C# or VB, you need to be aware of some subtle but significant differences. T-SQL, in fact, will handle a null differently than most CLR languages. Let's take a look at the following T-SQL statement and its output. Here we've declared two variables, one integer, one a variable length character, and we just asked SQL to select them. Because there are no values assigned to those variables, the results are null. And this is what we expect. But if we're to take a look at a VB.NET equivalent, what are the results? Here we have a subroutine. We're declaring two local variables. One is integer, one is string. And we're just going to ask it to display it in a message box. And here we can see that what VB returns is a 0 assigned to the integer and an empty string for the string variable, neither of which are nulls. So in the case of the VB.NET procedure, the CLR initialized the integer to a 0 and the character to an empty string, and that's not what we saw with the SQL equivalent code. So the outcome of queries, comparisons, logical operations, and arithmetic are quite different when null values are involved. So it's important that you handle these operations consistently when you're in a T-SQL or CLR procedure. Fortunately, there is a namespace dedicated to helping us. It's the .NET system.data.SQL types namespace. And that namespace makes integration between T-SQL and the CLR much easier. It contains the data types that more closely map to native SQL data types and provide a more consistent behavior. In this VB.NET procedure, we use the data types found in the system.data.SQL types namespace. Here you can see again we have a couple of local variables declared. This time the integer variable is declared as a SQL int 32 and the string as a SQL string. This time when we ask VB to indicate whether or not the variables have been initialized, you will see that we are getting true when we check the isNull property of both those local variables. And that's a behavior that's more consistent with native SQL. So when integrating T-SQL and CLR functionality, try to use the appropriate SQL types data types for your variables, parameters, and return types. The table that follows details these mappings. So in this table you can see the SQL Server native data type listed as well as its corresponding SQL type in the .NET framework SQL type namespace and the native CLR equivalent data type. Now, not every one of them have a one-to-one correspondence, but most of them do, so make sure that you use the appropriate one when writing your procedures. And as always, refer to books online for a complete listing. Here's a tip. While both the SQL cars and SQL string data types map the .NET CLR strings to SQL Server data types, Microsoft recommends using SQL string for performing string operations and SQL cars for data transfer and access. Let's go to SQL Server Management Studio and take a look at some of these data types. So in this very simple procedure, we're going to declare two variables. One is an integer, one is a variable length character, and we're just going to ask SQL to select them back out. And what you're going to find is because we haven't assigned any specific value, SQL is going to treat those as null, and that makes sense. That's what we want it to do. However, if we take a look at something similar in, say, a VB.NET procedure, which we will do right here. We're going to take a look at this little project where underneath this little VB.NET button, we'll jump down to a procedure that does something similar. And what it's going to do here is define an integer and a string, and then we're going to actually ask it to display the values. And if we take a look at this by running the procedure, we're seeing that we're getting back a 0 and what seems to be an empty string for the string variable. And if we go ahead and shut this down and come back here, we're going to find out that it hasn't been used. Notice that it does say no reference exception could occur, but in VB.NET we're actually going to have an empty string defined there, so everything's okay. But it's not the behavior that we expected. At least it's not the behavior that's consistent with what we're doing in SQL. So let's take a look at how that might be a little bit different. If we go ahead and run this again, this time taking a look at those types specific to the SQL types namespace, we can see that we're getting an answer where the integer value and the string value are coming back as nulls. It's indicating that that value is true. Well, how does that actually happen? Well, let's stop here, take a look at our form again, go underneath our SQL types button, which brings us to the procedure that we will execute when that button is clicked. Here you can see instead of declaring it as an integer, it's a SQL int 32, and instead of a string, it is a SQL string. We haven't assigned any values to these variables, and so when we ask it to display, we're asking it to display the isNull property, a Boolean, true or false. Is this variable a null? And as we saw just a little bit earlier, when we click that, sure enough, that's true because we haven't assigned any values. So just a very quick example of how you use the SQL types and how you can use the SQL types namespace to get behavior that's very consistent with SQL Server. So now let's discuss the ANSI nulls option. When the ANSI nulls option is turned on, SQL always returns an unknown value when you compare it against a null. Why is that? Well, it's actually very simple. Comparing a known value to an unknown value can't logically return true or false because one of the values is unknown. I don't know what it is. So in this little T-SQL segment, we see that we have the ANSI nulls option turned on, and we're asking it to return a set of rows where the title is equivalent to null. And we get an empty result set. When the ANSI nulls option is set to on, when you select anything that is equal to null, it always returns an empty result set because it's not equal to null, it's unknown. And it's actually the SQL 92 standard. It's really the ANSI SQL 92 standard that requires a different syntax. The equal operator does not really check for null equivalence when that option is set to on. If you want to properly compare against null, then the standard requires you use is null or is not null to do the comparisons. So if we just rewrite that last example, and instead of saying equal to null, say is null, you can see that we get results. And it's a very different result at that. Here's a tip. When you're integrating with the CLR, always remember that variables, parameters, and return values declared as a SQL type data type perform exactly as T-SQL does when the ANSI null option is on. However, Microsoft extended T-SQL to allow queries to use the standard comparison operators to check for the existence or absence of nulls. By setting the ANSI nulls option off, at either the database or the query label will change the behavior. So with the ANSI nulls off, comparisons against null values return a true or false. So here you can see we've turned the ANSI nulls off, and this time we are going to retrieve records again where the title is equal to null. This time we get the results. And so it works, but is it a wise idea? So whenever possible, use the ANSI standard is null or is not null clause. While the T-SQL ANSI nulls off option supports standard comparison operators, it's really just an extension of Microsoft's version of the T-SQL language, and the code produces different results in other ANSI compliant database systems. Let's go to SQL Server Management Studio and take a look at how this works. So here we are in SQL Server Management Studio again, and here we're going to show what happens when the ANSI nulls option is set to on. You can see that we have explicitly stated that, and that we are going to select some records from the AdventureWorks 2012 database, specifically from the person table, and we're looking for rows where the title equals null. And with the ANSI nulls option set on, that's going to return an empty result set because null is unknown. It's not equal to something. So it's an unknown value. There's nothing that satisfied the criteria, so there's an empty result set. But if we take a look at how to change that, we still have our ANSI null set to on. This time we're going to use the ANSI SQL 92 standard and use the isNull operator to find out whether or not any of these titles are unknown or null. And so if we execute this, you can see sure enough we are getting rows back that have null titles, and that's the behavior that we expect. However, Microsoft gives us an option to override the standard behavior. And in this case, what we're doing is we're explicitly saying to turn off ANSI nulls, go ahead and run the same query again, this time going back and checking for equivalence. And when we do that, you'll see that now this is working, but although perhaps not the way we really want it to. This is an extension to T-SQL that Microsoft implemented. I would recommend that you use the ANSI standard, not the Microsoft extension, and change that equal sign to is. So now let's discuss the SQL Boolean data type. The outcome of performing arithmetic, bitwise, and logical comparisons when you're dealing with variables that have null values can be inconsistent. The ANSI nulls option in T-SQL proves just how different the results can be. The simple VB.NET example showed that not using the SQL types actually led to that confusion. The .NET Framework SQL Boolean data type actually comes to the rescue here. It's exposed as part of the SQL types namespace, and it represents three distinct states: true, false, and unknown. Comparison of two SQL types data types always returns a SQL Boolean. And the SQL Boolean data type has three important properties. Is true. That indicates if the comparison produces a true value. Is false, the outcome is false. Is null returns true when the comparison between the variables produces an unknown or null result. So if we want to assign null values, you'd think that'd be a pretty straightforward operation. But T-SQL and CLR languages provide different ways to assign and interrogate null values, including considerations for CLR integration, T-SQL direct assignment, null if, and coalesce, two SQL functions. When we're talking CLR integration and we're integrating with the .NET CLR, use data types found in the System Data SQL Types namespace. Native CLR data types do not allow for the direct assignment of a null value. Data types in the SQL types namespace do. So what do we mean by direct assignment? For T-SQL programmers, it's the most familiar. Here we're doing a simple update statement. We're explicitly setting the value of a title to null, changing it from something possibly known to unknown. But in other cases, you might need to assign or interrogate to see if the values are null. Perhaps we have to return a null if other values within the row contain certain values. Or maybe we have to dynamically replace nulls. NullIf is a function that evaluates two expressions and will return null if they are equivalent. Otherwise, it returns the first expression. So the syntax here is NullIf and in parentheses expression 1 and 2. If those two expressions are equivalent, we'll get back a null. If not, whatever the first expression is returned. And as I said earlier, in other cases you might need to actually interrogate the null value and see what you're going to assign. Perhaps we want to do this dynamically, which is what the coalesce function does for us. Coalesce actually looks at a series of expressions and will return the first non-null value from the list. And here we can see we have coalesce and then one or more expressions. If all of the expressions evaluate to null, the function returns null. That makes sense. Nothing was defined. Everything was unknown. And it's a handy function for formatting output. Let's go on over to SQL Server Management Studio and take a look at how these functions behave. So here we are back in Visual Studio. We're going to take a look at our VB.NET procedure for assigning nulls. And the first thing we want to look at here in this procedure is we have declared two variables as SQL int 32s. We've assigned one of those variables a value. And here's the syntax for assigning a null value. SQL int 32.null. That means that variable declared as a SQL int 32 now has the null or unknown value. And then when we ask it to display results saying, hey, are you in fact null, we should see that this is not a null and that this one was assigned one. So we should get true for that. And if we execute this, sure enough, we're getting false for int x and true for int y. So you can see it's very simple, very straightforward to assign true null values to variables declared using the SQL types namespace. Now if we go back to our project and take a look at going one step further, working with SQL Booleans, we have to remember that the result of interrogating a SQL types data type is a SQL Boolean, a result that will return true if the two values are equivalent. It'll return false if it's not equivalent, and if one of them happens to be null, one or both of them I should say, then it'll return a null value. So let's go ahead and run that and take a look at the results. Well, we assigned the number 5 to that int x, so the fact that it is not a null should not be surprising. We directly assigned a null value to int y, and we can see here that it's returning true. It is in fact null. And when we ask it to do the comparison here, is int x equal to int y, the answer is false. One is a 5, something defined, and one is null, the unknown value. So here you can see working with the SQL types data types is really the way to go. Okay, so let's now go back to SSMS. Let's minimize this. Come back over here and take a look at a couple of quick examples. Here's just an example of updating a record, assigning a null value to one of the columns. Very straightforward, something that should be familiar to most out there. and we're just going to directly assign a null to a title where that record identifier is 24, that primary key. And if we execute that, we should get back indeed that one row was affected by our action. So that in T-SQL is a way that we directly assign a null value. Nothing surprising there. This particular example takes a look at coalesce. This is one of those functions that can really help us kind of manipulate and work with null values. And here what this is saying, this is the portion that's interesting, is the coalesce function says, well, I'm going to look at this value first. If it is a null, then I am going to return this empty string. And if it's not null, then I'm going to return the middle name plus a space. And this is going to be used to format the output. So you can see here that we're going to display the first name with a space, and then depending on the outcome of this operation, if there's a middle name defined, then we will return the middle name with the space, otherwise an empty string, and finally the last name. So if we go ahead and execute this, you'll see that indeed some of them actually have middle initials displayed and some do not. So our coalesce is going in there and examining that value and doing something if indeed the value is null.